Okay, so welcome to lecture number 1 of chapter 6. Now we are going to start new chapter today, that is chapter number 6. The name of chapter is General Principle and Processes of Isolation of Elements, or you can say it is Metallurgy chapter. Now you have learned some of these methods in 10th standard. In GSEB book there were some methods like froth flotation method, blast furnace, etc. That method we are going to learn in this chapter. So it is very easy for you because you have learned that topics in 10th standard also. So I am going to start this chapter with 3 definitions, and these definitions are not given in your book. So first definition is for gangue, then minerals, and then ore. So first, what is gangue? Now gangue is usually ores are contaminated with other undesired material like dust, sand, etc. These undesired materials are called gangues. Suppose I am getting a rock of iron. Now that iron rock must contaminated. There must be some soil or silica will be there, or some iron rust will be there. So this type of material, they are called undesired material, and it is known as gangue. Now second term is important, minerals. Now many of you are confused between mineral and ore. So mineral are rock that contains metal in any percentage. Suppose I got a rock and that have 2% of iron only 2% of iron is there. That rock can called mineral, that is mineral of iron. But in case of ore, the definition is different here. A rock that contains metal and from which we can extract metal profitably, that are called ore. Now understand that with an example. Here you can see 2 rocks are here, rock number 1 and rock number 2. Now first rock contains 70% of Fe and second rock contains 30% of Fe. Now you can see rock 1 is having more Fe here. So from the percentage you can say that our rock 1 is ore and rock 2 is not ore. Rock 1 and 2, they both are mineral. They both can called mineral, but only rock 1 is ore here according to percentage only. Now there are some other factors to consider rock 1 as ore. Suppose the expenses are more in case of first rock. Suppose I guess to get Fe from rock 1 I have to spend more money. Suppose I am taking 1000 rupees, and to extract Fe from rock 2 I have to spend some 200 rupees only. So in case of that, rock 2 will be our ore because the expenses are less in case of rock 2. So there are multiple factors that are considered to call a rock ore. Okay, so here this term is very important, profitably. Both rock have our metal, but which from which we can extract metal profitably, that rock is called ore, and both are called mineral because both are having metal in any percentage. Now, third point, the extraction and isolation of metal from ore involves three major steps. First one is concentration of ore. We are going to extract metal from the ore. Now that contains three steps. First step is concentration of ore. Second step, that is isolation of ore from concentrated ore. And third step, purification of metal. Again, concentration first step, second isolation, and third one is purification. Now, the entire scientific and technological process for purification of metal is known as metallurgy. So our chapter is basically metallurgy chapter. Okay, the entire scientific and technological process from which we can get metal from ore, that is called metallurgy. Now, in our environment, in earth, air, etc., there are metals in different proportion. Some metals are more abundant and some metals are less abundant. So among all elements, aluminium is the most abundant element, iron is second most abundant element. Now here a table is there. Here you can see aluminium, these are the ores for aluminium metal: bauxite and kaolinite. Now you have to remember these formulas, it is very important for MCQ. Bauxite has not fixed formula because some impurities are in different proportion at different places. So AlXOX into OH thrice minus 2x, that is the general formula of bauxite. Kaolinite Al2OH 4 times Si2O5. Now iron have total 4 ores: hematite, magnetite, siderite and iron pyrites. Now from that, many times the formula of siderite and iron pyrites are asked as MCQ in board exams. Siderite and iron pyrites. Hematite, that has formula Fe2O3, then magnetite Fe3O4, then siderite FeCO3, ferrous carbonate. The name of this general name, scientific name of this ore, siderite, is ferrous carbonate. Iron pyrites FeS2, ferrous sulfide. The scientific name of iron pyrite is ferrous sulfide. Then copper, the ore is copper pyrites, malachite, cuprite, copper glans. You can see the formulas here. The formulas are very important. It can be asked as MCQ. Zinc, zinc blende, calamine and zincite. Now mostly aluminium is extracted from bauxite ore and iron is extracted from oxide ore of iron. These ore were selected because they do not produce any polluting gases. Now The first step of metallurgy was concentration of ore. Now, what do you mean by this term concentration of ore? So here, removal of unwanted material such as sand, glass, etc. from ore is known as concentration or dressing or benefaction. Simply, you can say the ore is bathing here. The sand or soil particles that are on the ore, that is cleaned up here in this tab. Now this involves several steps. Concentration involves several steps, and these steps are depending on physical property of compound, then type of metal we are getting, available facilities, and environmental factors. From these four factors we can decide the steps for concentration of ore. Now here few methods are given for concentration of ore. First method, that is hydraulic washing. Second method, magnetic separation. Third method, froth flotation method, and fourth one is leaching. So here one by one we are going to learn that four methods. First one, hydraulic washing. Now in the name only it is given that it is washing, and hydraulic means by pressure it is washing. So this method is based on differences in gravities of ore and gangue. This sentence is very important. The method is based on the differences in gravities of ore and gangue. So it is type of gravity separation. Now what do we do in this method? So in this method, an upward stream of running water is used to wash powdered ore. Okay, so when our ore is in powder form, the stream of water, we are washing the ore by the stream of water, and this water will come in force, and the water will come from upward direction. Okay, so what will happen here? The lighter particle will go away with water and heavier particle will left behind. Okay, so this is hydraulic washing. Now the second method, magnetic separation. So in the name only it is given that it is magnetic separation. So this method is based on differences in magnetic property. If one of ore or gangue is capable of being attracted toward magnetic field, this method is useful. Okay, one of the component, ore or gangue, that must be attracted toward magnetic field, then only we can apply this method. In this method, a ground ore means powdered ore is carried on conveyor belt which passes over magnetic roller. You can see figure here. Finely ground ore means powdered ore is there, and this is our magnetic roller. This black part is our conveyor belt. Now whichever compound is attracted towards magnetic field, that will come here in red part, and whichever compound is non-magnetic, it will come here in yellow part. So this is magnetic separation. Now the third method is froth flotation method. Now this method is useful for sulfide ores, and this method is very important. This method is can be asked in 2 marks, so prepare it very carefully. Froth flotation method, IMP है. So this method is useful for sulfide ores. In this method, what we are doing here? So first, suspension solution is made up with water and powdered ore. First, make a solution of water and powdered ore. Then add some collectors and stabilizers into it. Now these are example of collector: pine oil, fatty acid, xanthates, that are example of collector. Now why we are adding this collector? So collector are added because collector enhance the non-wettability of mineral particles. It enhance the non-wettability of mineral particles. Now second word was there, stabilizers. Now these are example of froth stabilizers: cresol and aniline. Now why we are adding these froth stabilizers? So it stabilizes the froth. Now after adding this 4 compound, water, powder ore, collector and froth stabilizers, after mixing these 4 components, the mineral become wet by oil, while gangue particles are wet by water. Now by rotating pedal, we can draw air in the mixture. You can see this one is our rotating pedal. Now from here we can insert air into the mixture. We can add some air into the mixture. Okay. Then as result, when we are inserting some air, as result froth will be formed which carries mineral particles. Okay, because of air, froth will be formed and it carries mineral particles only, not gangue. This froth is light in weight and it is taken out from upper surface. You can see here the froth is on the upper surface of liquid. So just take it out from the upper surface and collect it in another vessel. Now one another advantage is there of this method. Sometimes it is possible to separate 2 sulfide ore using this method. For that we can adjust proportion of oil and water using depressant. Now this term is new. What is depressant? So depressant is nothing but a compound that make a ratio, suitable ratio between oil and water. Suppose we have 2 sulfide in ore, suppose that are PbS and ZnS. Now we are adding depressant here. As depressant we have NaCN, sodium cyanide. Again, the name of this compound is sodium cyanide, and it is used as depressant in froth flotation method. So what will it do? It will resist the entry of ZnS in froth. Again, what will it do? It will resist entry of ZnS in froth. It will not let ZnS enter in froth. So in froth only PbS will be there, and ZnS will remain in water. So we can separate these two sulfides here. Both are sulfides. We can separate it using depressant. Now the fourth method is leaching. So if the ore is soluble in some suitable solvent, leaching is used. Example, first one is leaching of alumina from bauxite. Now here our ore is bauxite. Now in bauxite, silica SiO2, iron oxide or titanium dioxide are there as impurity. Now we want to remove these impurities. So what we are doing here, just make powder form of ore, then this powder is processed with concentrated NaOH at 473 to 523 Kelvin temperature and 35 to 36 bar pressure. So what will it do? This reaction will give us, here you can see, Al2O3 converts into sodium aluminate and SiO2 will convert into sodium silicate. The reaction is given to you, Al2O3 plus NaOH plus H2O gives 2NaAlOH 4 times. This one is sodium aluminate, NaAlOH 4 times. It is known as sodium aluminate. Now after making this sodium aluminate solution is then treated with carbon dioxide gas. So what will it do? It will make precipitate of Al2O3 alumina. In it is hydrated alumina. Now it takes some more time to precipitate alumina. So to reduce the time, we are adding some freshly prepared hydrated Al2O3. Here you can see at this stage fresh hydrated Al2O3 is added as seed into solution, so we can get Al2O3 precipitate. Okay, so here if we don't add this fresh hydrated Al2O3, what will it do? It will take some more time. Now it is very expensive method, so for reducing time we are adding fresh hydrated Al2O3 as seed here. So it will reduce time for the formation of precipitate. The reaction is here. This is sodium aluminate plus carbon dioxide gas. It will give hydrated alumina Al2O3 into XH2O plus sodium bicarbonate NaHCO3. This hydrated alumina is then filtered out and heated to give pure Al2O3. Here you can see Al2O3 into XH2O gives, it is heated at 1470 Kelvin temperature. So water will evaporate from the hydrated form, so it will give pure alumina plus water will be evaporated here. Now here sodium silicate was there as impurity, and that remains in the solution. You can say the solid hydrated alumina is filtered out. Here it was filtered out, but sodium silicate remains in the solution, so that impurity was also taken out. Now the second example is there, and it is of silver and gold metal. Now these metal are leached with sodium cyanide or potassium cyanide. The solution of dilute NaCN and KCN is reacted with metal silver and gold in presence of air. Here you can see the reaction is there. Metal, as metal we have silver or gold plus 8Cn minus, Cn minus we can take NaCN or KCN here, plus H2O plus O2 gives metal cyanide M, that is Ag or Au, plus OH minus. Now from the product, this MCN2 minus cyanide product, metal is obtained by replacement. So here Zn is replacing metal here. In the next reaction, Zn is replacing the metal. You can say Zn he is replacing the metal, and we are getting here metal in pure form. So this is leaching of metal. So that's it for today. Thank you.